So in last class, we have discussed all about the basic definition of different component of moment of inertia tensor. And we have basically moment of inertia, product of inertia, and principal moment of inertia. All are have different role to understanding the moment of inertia. Let's try to go for straightforward one very basic problem, but very interesting one. So let's try to go for this. And this is for the two-dimensional one. So we are into XY plane. And before starting this particular question, just tell me, is that moment of inertia tensor will depend on choice of origin, or it will be independent of choice of origin? Anyone?
Independent of choice of origin.
This is independent of choice of origin.
Dependent.
That is highly dependent on choice of origin. Why? Because what is x1 and y1? They are coordinates, isn't it?
Yes, sir.
Suppose I am talking about first particle, that is x1, y1, and z1. And this x1, y1, and z1 will be changed if you will change the origin, isn't it?
Yes, sir.
So if you are changing the origin, then everything or the whole symmetry is going to change. I am just telling you this particular thing. Look at here. We will discuss this type of problem also. Suppose I have this sort of a square plate and origin is at the center of a square plate. This distribution of mass is entirely different with respect to origin. Suppose this is one case and there is another case. Okay. Suppose this is another case. The same, this is square, some same plate is just keeping something like this. And here is my origin. Here is my origin. So what will happen if we will change the origin? The limit is going to change. The coordinate is going to change. So if this kind of thing will happen, then obviously the moment of inertia tensor will be changed. So you have to very much careful that where is the origin of the coordinate system, because it is just our methodology to understand the particular system and particular distribution of inertia, mainly in rotation sense. So why we are saying it moment of inertia. Okay, so let's try to go for one very basic question, and I will just give you this question, and we will discuss a lot of things into this particular question. It's a very interesting. So this is my origin. So this is my first mass, this is my second mass, this one is my third mass, and this one is my fourth mass. So first mass is, let's say, m, second mass is, let's say, 2m, third one is 3m, and this one is 4m. Okay, and this is my origin, and the coordinate of this mass is, let's say, -a and 0. The coordinate of this mass is a and 0. The coordinate of this mass is a, and coordinate of this mass is basically -a and a, isn't it? So this is discrete mass, and what we want to do, we want to calculate the moment of inertia tensor. This is our first duty, and after then I just want to calculate if the whole system, suppose you have, this is massless rod and you have two masses here, one mass is here at this one paper, and this is just going to rotate something like some angular velocity, and that angular velocity is, let's say, basically 0 omega naught 0. Suppose this is my angular velocity. Angular velocity is some vector quantity. So this is my angular velocity. So what we have to do, we have to calculate first moment of inertia tensor, and then we have to calculate the angular momentum. Hence it is rotating, the whole system is rotating somehow, and how it is going to rotate, that is a different issue, but it is rotating somehow with this particular angular velocity. And I have written this thing in vector quantity or in matrix quantity. So we have to calculate the angular momentum also. So obviously this is given in xy plane. So I can say this is x and this will be y. So what will be your moment of inertia tensor? So before going to that, can you please tell me which component will be 0? Which component will be 0?
Z component will be 0.
Z component means I x z is equal to I zx is equal to summation over minus mi xi zi. So for every particular mass, zi is equal to 0. So this is going to 0, isn't it?
Yes, sir.
Similarly, I have I yz is equal to I zy is equal to minus summation over mi zi zi is equal to 0. So obviously these 4 components are 0. Now what we have to do? We have to calculate the all other components. So first we will calculate the diagonal term. What is the name of diagonal term?
IXX, IYY.
So that is known as what? Moment of inertia actually, है ना?
Yes,
So
sir.
हम लोग diagonal term calculate करेंगे first. So let's try to calculate IXX. What is formula of IXX? Summation over mi yi square plus zi square. Isn't it? ऐसा है ना? So what will happen to this particular zi is always 0. So you can just go for first component is m into 0 whole square. I am saying this one is first, this one is second, this one is third, this one is fourth. Plus 2m into 0 square plus 3m into a square plus 4m into a square. That value is 7 ma square. Everyone is comfortable? ठीक है ना? Let's try to calculate IYY. So IYY is mi xi square plus zi square. Again zi is 0. So what will happen? So that value is equal to m into minus a square plus second is what? 2m into a square. Third one is what? 3m into a square plus 4m into a square. So what will happen?
10 ma square.
10 ma square. So that value is 10 ma square. Now what will be IZZ? So we have IZZ, that is summation over mi xi square plus yi square, isn't it? And when we are going to calculate this particular thing, then what will happen? We have already calculated mi xi square. We have already calculated mi yi square, isn't it? So that value is equal to 17. So you can just write mi xi square is 10 ma square plus that will be 7 ma square, and that value is equal to 17 ma square. Now, have you smelled something? कुछ स्मेल किए हो जो आप पहले से जानते हो?
Perpendicular axis theorem.
That is something like perpendicular axis theorem. So distribution of mass in xy plane. So we have distribution of mass in xy plane, and what we are going to do? We are just going to calculate the IZZ is equal to IXX plus IYY. So this is perpendicular, and perpendicular axis theorem is only applicable when your mass are confined into a plane. Okay. Great. Now we have last part. Last thing is remaining here. What will be last thing? I x y. जरा फटाफट कैलकुलेट करो तो क्या आ रहा है?
MA square.
So that value is equal to ma square. How you will know? First term is 0. Second term is 0. What will be third term? Minus 3m a into a. And what is fourth term? Minus 4m. And that value is equal to a into minus a. And so why this value is ma square. Okay. So this is my moment of inertia tensor. What is my moment of inertia tensor? Ixx 7 ma square. This is ma square, that is 0. That is ma square, 10 ma square, 0, 0, 0. And what will be this particular thing? 17 ma square. Okay. And now this is your moment of inertia tensor. This diagonal term is actually moment of inertia, जो हम लोग पहले +2 में basically पढ़ते थे, है ना? So we are just talking about only that part. So this is your diagonal term, and there are two survival this product of inertia. All other term is 0 actually. So let's try to go for finding the angular momentum. So what will be angular momentum? If this is some hypothetical case we are taking, omega is something 0, omega not 0. So what will be your angular momentum? Angular momentum is nothing but I into omega, isn't it?
Sir.
Huh. So this angular momentum, हाँ बताओ. Yes.
So this IXY sir plus 3 ma square minus 4 ma square.
Huh. So this is ma square,
So plus 3 minus 4 minus ma square.
and here is a 1 minus here is also okay.
Okay, sir.
So this will be minus minus plus. This is plus. Okay. Are you getting it? मिल रहा है आंसर?
Yes, sir.
So this will be plus or minus? कौन पूछ रहा था?
Yes, sir. Plus plus.
प्लस. ओके. सो कैलकुलेट अच्छे से करना है, ठीक है? ओके. So what will be my angular momentum? So angular momentum is equal to I into omega. And when we are going to calculate I into omega, then we have 7 ma square, 0, ma square, 10 ma square, 0, 0, 0, 17 ma square, and I have 0, omega naught, 0. What you will get? The first term is what?
MA square omega naught.
Omega square omega naught. Second term is
10 MA square omega naught.
10 ma square omega naught. What about third one?
0.
0. So I can write this thing as, you can take ma square outside. You have omega naught, 10 omega naught, 0. Now you can see angular, the velocity is in direction of y cap, but this angular momentum have direction of x cap as well as y cap. Due to this particular, what you can say, this particular distribution. So अब मैं आपको इसी चीज को, and now you can see the masses are also changed, isn't it? The masses are also changed. Now suppose I am giving you one homework and just try to give the answer. Just try to do it with yourself. Suppose I am giving this much of concept and every mass is m. And this will be minus a0. Sorry, this will be minus a and minus a, isn't it? And what will be this one?
A comma
A and minus a. What will be this one? A and a. This will be
minus A and A.
minus a and a. Okay. And now you have the same angular moment, same angular velocity. Just try to find the angular momentum. This is your homework. Just try to do this thing.
सर
Hmm.
जो थर्ड क्वाड्रेंट में ना उसका कोऑर्डिनेट्स क्या है ए और माइनस ए और
तुम्हारे हिसाब से क्या होना चाहिए बताओ?
दोनों नेगेटिव चाहिए लेकिन वो एक ही -1
कौन सा? ये वाला?
हाँ थर्ड वाला
तो दोनों ही नेगेटिव तो है, माइनस है.
ओके
ठीक है? Okay. Just try to do this thing and then we can discuss little bit more into next class. But first you have to just try to understand what is going to happen. Okay? ये गलती कभी भी मत कीजिएगा कि इसके जस्ट परपेंडिकुलर डिस्टेंस लेकर के कैलकुलेट कर ले. So only you will get this one. This component you will never get. Okay? है ना? What is moment of inertia? Moment of inertia is basically this one. This is about y-axis. So this is your distance. This is your distance. So you will get only this one. So you have to all, and if it will be, agar ye diagonal matrix hota, then obviously the direction of omega and direction of angular momentum will same. Okay? Clear hai ye? Chalo. Let's try to go for obviously, and the discrete masses are just counting this thing, how you are going to write it in a very simple way. So let's go for continuous system, and where you have to apply all the integration and all this kind of thing. Clear hai ye? Okay, let's try to go for this one. This is one of my favorite question, and from here we can learn lot of things. So this is mainly a rectangular shape, and the mass is m. This is your distance a, this is your distance b, and this is my origin o. Okay, so what we have to do, we have to calculate the moment of inertia tensor for all this particular thing, and here is origin. Okay, here is origin, and this is in x and y plane. So again it is in x1 y plane, and we have to just go for calculating the moment of inertia, and we will also try to calculate principal moment of inertia and principal axis. So everything we are just going to calculate. Exam में क्या पता क्या देते है ना? So everything we have to calculate, and we will calculate principal moment of inertia for b is equal to a, such that calculation will be little bit easy. So we will calculate it for b is equal to a. So let's try to calculate each and everything from here. So which term is again going to 0? Just tell me. I will start from here. Okay. Which term is going to 0?
xz and zx.
xz and izx is equal to 0. Iyz is equal to izy is equal to 0. Okay, that's it. So these four terms is 0 because the mass is distributed in a plane. Okay. Now let's try to go for a calculation of all the diagonal term. And what is name of the diagonal term?
Moment of inertia.
Moment of inertia. Okay. So let's try to go for Ixx. Now, what is formula of Ixx?
For discrete.
Obviously, we have to use here not discrete. We have to use here what? Continuous system. So what is formula of Ixx?
Integration dm
Integration dm
z square
y square plus z
z
square. Very good. So this is all about Ixx. integration dm y square plus z square. Now, what is z? That is 0. So that value is dm y square. Now the whole challenge is that we have to write dm as a function of dx and dy. So I can write m into ab. Hence it is a constant density. So this is my density. This is something like sigma. Everyone is comfortable?
Yes.
And this can be equivalent to dm upon dx into dy. And this should be what? Single integration or double integration?
It's a double integration.
Double integration, because the mass is distributed in a area. So we have to go for what? Double integration. Okay. So what will be my dm? My dm is equal to sigma dx dy. In the examination, they will give you sigma if it will function of x and y, or you have to just go and you can just take the ratio if they are constant. So here is constant, and we can just go for m upon ab dx into dy. Yes. So what will happen? So we have m upon ab is constant, and now x will go from where to where? 0 to a. And you have dx here. Again, this is y square dy 0 to b. What will be final value? mb square by 3. Isn't it? This is my xx. So now from the symmetry, can I write iy? क्या होगा iy?
me square by
A square by 3.
Obviously. So you can see you are just using this particular concept of moment of inertia, the perpendicular distance into dm, isn't it? And perpendicular distance to y is x. So you can use this thing. We will discuss it in a next class actually. So this is my mb square by 3. Okay. So I can write directly I yy. What will be I yy? M a square by 3. What will be zz? Can we use perpendicular axis theorem?
Yes, sir.
Yes, we can use it. Okay. So when you will use it, that value is equal to m by 3 a square plus b square. Now, last but not the least, we have to calculate ixy is equal to iyx. What is this value?
Minus MAB by 4.
Very good. Minus MAB by 4. What is my formula? My formula is minus dm x into y. Dm will remain same. And this value is integration m upon ab x dx y dy. We will go for 0 to a. We will go for 0 to b. So that value is minus m ab by 4. ये आ रहा है ना? So this is my moment of inertia tensor. Now look at, if suppose you have the same mass or same mass and it is just kept like this, then what is going to change?
Origin.
Origin हमने change कर दिया है ना? अब ये कहां से कहां जा रहा है? Minus a by 2 to plus a by 2, and this is going to 0 to b. Okay, y is going to 0 to b. So y में कोई change नहीं आ रहा है, x में हमने change कर दिया. We are just shifted our origin towards right. And now this is your homework that you can easily calculate what will be moment of inertia in this particular case. Can you calculate it? हो जाएगा? Same thing, nothing else. And you will see, you will get the different moment of inertia tensor because you have changed origin. Okay. Okay. So what is this particular moment of inertia I, that value is equal to what? क्या रहा है पहला? mb² by 3 minus mab by 4, 0, and we have minus mab by 4, ma² by 3, 0, 0, 0, ma² plus b² by 3. So this is our moment of inertia tensor for this case. So let's try to calculate a principal moment of inertia, and we will also calculate basically the principal axis. What is principal axis?
Direction in which I is diagonalized.
Very good. So what will be that thing mathematically? Physically, it is absolutely correct. So what will be mathematical thing?
That eigenvector corresponds.
Eigenvector corresponds to
Eigenvalues. The principal moment of inertia.
corresponds to
Singular
principal
inclusion.
moment of inertia. Very good. So first we will calculate principal moment of inertia. यहाँ तक clear है ना हर एक लोगों का? We have to calculate it for b is equal to a. Okay, मुझे b is equal to a के लिए calculate करना है. So what will be moment of inertia tensor now? So I will use a ma² by 3 minus ma² by 4, 0, minus ma² by 4, ma² by 3, 0, 0, 0, and what is this? 2 by 3 ma². So this is my moment of inertia tensor if it is square. Okay, so I will also remove this one because it is unnecessary keeping the space. Okay, now we have to calculate principal moment of inertia. So what is principal moment of inertia? The eigenvalue of this matrix, isn't it? What is principal moment of inertia? This is nothing but what? Eigenvalue of this matrix. So that will be I minus lambda u must be equal to 0. U is nothing but a unit matrix. In general, we are using I for the unit matrix, but here I is moment of inertia. So I am using U as a unit matrix. Everyone is comfortable? Okay. So what will happen? So we will just go for ma² by 3 minus lambda minus ma² by 4, 0, minus ma² by 4, ma² by 3 minus lambda 0, 0, 0, 2 by 3 ma² minus lambda. That must be equal to 0. So we can expand about this axis. So about this particular row, or this will be 2 by, sorry, that is 2 by 3 ma² minus lambda into, we are just going to multiply this thing. So we have ma² by 3 minus lambda whole square minus this is ma² by 4 whole square, isn't it? And that must be equal to 0. ठीक है ना? Minus minus is plus and one minus will survive. So you can use a plus b into a minus b, isn't it? So 1 lambda is equal to 2 by 3 ma². I will keep it lambda 3, don't worry, because I have this particular thing at here 3 and 3. So this will be, I am just saying this is lambda 3. What will be lambda 1 and lambda 2? You can use a² plus minus b² formula. So what will happen? ma² by 3 minus lambda plus ma² by 4 must be equal to 0. And from here, we have, what is this particular thing? 7 by 12 ma square. And what is next? Let's say this is lambda 1. What is lambda 2? 1 by 12, isn't it?
Yes, sir.
Just calculate it.
Yes, sir.
So that value is ma square by 3 minus lambda minus ma square by 4 must be equal to 0. So from here, lambda is equal to ma square by 4. So we have 3 different principal moment of inertia. What are these things? So lambda 1 I am keeping as 7 by 12 ma square. Lambda 2 I am keeping 1 upon 12 ma square. And lambda 3 I am keeping 2 by 3 ma square.
सर नीचे का नहीं दिख रहा.
सर
अरे
थोड़ा
कैलकुलेट करो यार. दिख रहा है, उतारना जरूरी होता है. हाँ, दिखा? कैलकुलेट करो, है ना? कैलकुलेट करो, आइगन वैल्यू निकालने आता है ना? हाँ या ना?
जी सर.
निकालने आता है आइगन वैल्यू? हाँ, चलो निकाल करके देखो सी आ रहा है कि नहीं. खुद साथ साथ सॉल्व करने की आदत डालनी है, ठीक है? उतारना तो जस्ट ठीक है कि हमने जो सॉल्व किया वो सही है या नहीं. ओके, यू आर नॉट अ स्टूडेंट ऑफ आर्ट्स, यू आर अ स्टूडेंट ऑफ साइंस. So you have to do with yourself in a class itself. ठीक है? Anyway, यहां तक क्लियर है ना?
Yes, sir.
ओके, चलो मैं किसी एक का निकालूंगा. So you can write it I1, I2, I3 also. So this will be I1, this will be I2, this will be I3. So I3 का क्या आएगा? डायरेक्ट I3 के corresponding आइगन स्टेट, आइगन वेक्टर क्या आएगा? कोई बता सकता है? This is degenerate or non-degenerate?
Non-degenerate.
Non-degenerate. बताओ I3 के अबाउट क्या आएगा?
So 001.
001. Okay, so I am just writing x3 as 001. You can see, है ना? This will be 001. आप कैलकुलेट करोगे, you will get exactly same thing. दोनों में से बताओ किसका निकालो और किसका आप निकालोगे? मैं किसका निकालूं?
Lambda 1 का.
हाँ, lambda 1 का निकालूं. चलो फिर मैं lambda 1 के लिए निकालता हूं. So what will happen? So you have m a square by 3 minus ma square by 4 0 minus ma square by 4 ma square by 3 0 0 0 2 by 3 ma square. And let's say यहां तो a दिया हुआ है तो मैं इसको x1 y1 z1 लिख दूं. फर्स्ट वाले के लिए बोल रहा है पुनित, सो वी विल जस्ट गो फॉर 7 by 12 ma square. So ma square is everywhere, so it will cancel out, है ना? ठीक है?
Yes, sir.
So what is first equation? First equation is x1 by 3 minus y1 by 4 must be 7 by 12 x1. First equation तो यही होगा, ठीक है ना? What is second equation? Minus x1 by 4 plus y1 by 3 is equal to 7 by 12 y1. Clear है ये? And last equation is 2 by 3 z1 is equal to 7 by 12 z1. So what is meaning of that? Z1 must be equal to 0. So from here, Z1 must be equal to 0. Now, you can just check from here. Is that both equation are same or different? इधर x1 लेकर के आओ या इधर y1 लेकर के आओ, दोनों सेम आ रहा है या डिफरेंट आ रहा है? देखो तो
सेम आ रहा है सर।
सेम आ रहा है ना? So what from both this equation, what you will get? You will get minus y1 by 4 is equal to क्या आ रहा है? y1 by 4, isn't it?
Yes, sir.
So this will be 7 by 12 minus 1 by 3 x1, यही है ना? So this value is equal to 7 minus 4 by 12 x1. So what you will get? You will get minus y1 by 4 is equal to x1 by 4. यही आ रहा है ना?
Yes, sir.
Just check it. दूसरे से भी यही आएगा. Just check it. So from here, what is conclusion? What is conclusion? x1 is equal to minus y1. So if you will take x1 is equal to minus y1, then you have x1 minus x1 0. This is your principal moment of inertia. You can normalize it. So this value can be written as what? 1 by root 2, 1 minus 0. So you can just go for do homework for this and just try to get what will be moment of inertia, principal moment of inertia about this axis. Okay?
Yes.
है ना? And you will get something like this. Don't worry. मैं लिख देता हूँ 1 by root 2, 1, 1, 0. आपको यहाँ से ये मिलेगा. Okay? So now what is meaning of that? If you will choose these as your x-axis, y, these your axis, then your moment of inertia will appear something like, कैसा appeared होगा?
Diagonalized.
Diagonalized. और diagonal term में क्या आएंगे?
Principal moment of inertia.
Principal moment of inertia.
Axis
अगर
diagonal
इसको अगर आप axis मानोगे, then you will get principal moment of inertia in a diagonal term. Okay? Are you getting my point? और डायगोनलाइज कैसे करते हैं? ये सारा आलोक सर ने बताया होगा. You will write U inverse moment of inertia tensor U. You will get a diagonal matrix, isn't it? और U किसके बेसिस में लिखोगे? They are written in a basis of eigen state or eigen vector. Clear है ये?
Yes, sir.
है ना? So this is part of matrix, so you can do practice. But इतना deep में कोई नहीं पूछ रहा है अभी. Just they will just ask what will be principal moment of inertia, what will be moment of inertia tensor. इस तरह की चीजें आपसे पूछी जा सकती है. Okay? Everyone is comfortable?
यस सर।
है ना? बहुत आसान टॉपिक है. जस्ट आपको समझना है क्या करना है ना? Let's try to go for one more problem. चले क्या? वेरी फास्ट करेंगे और एक बार में ही सारा लिख देंगे, है ना? बिकॉज अंडरस्टैंडिंग द सिमेट्री इज वेरी इंपॉर्टेंट. ये आप दिमाग में रखो. ओके? चलो. सो दिस इज अ समथिंग पैरेललोपाइप्ड. देखना इससे फिगर उतना अच्छा तो बनता नहीं है, बट यू कैन एज्यूम. लग रहा है कुछ ऐसा, है ना? एंड ऑरिजिन इज एट वन कॉर्नर. So this is my x-axis, this is my y-axis, and this is my z-axis. Along x-axis, it has a length. Y-axis, it has b length. This is x, this is y, and this will be your z. And along c-axis, it has z. The mass m is constant throughout the cube, and this is solid cube. Okay, this is something like solid cube. Clear है ये? So what you have to do? You have to just calculate IYY and IXZ. बाकी तो आप अपने आप लिख लोगे. So what will be IYY? DM and what is formula? फटाफट बताओ.
square plus y, z square.
x square plus z square. Okay. So this is single integration, double integration, or triple integration?
Triple integration.
Triple integration. Great. So you have to just go for what? Triple integration. So now, which coordinate system is best one? Cartesian or any other another?
Cartesian.
Cartesian, because this is just a linear symmetry of a distribution of mass. So can I write dm upon dx dy dz is equal to m upon abc? लिख सकते क्या?
Yes, sir.
है ना? dm upon dv is equal to total mass by volume. So what will be my dm? So dm is equal to m upon abc, and you have triple integration. So first integration, and now you should go something like this: dx dy dz x square, and you have triple integration plus dx dy dz z square. Are you getting my point? समझ रहे हो या नहीं? Because this will multiply with both the thing when this is in plus. गलती मत कीजिएगा, बहुत ही ज्यादा गलती होती है यहां पर. एंड ए कहां से कहां तक जाएगा?
0 to a.
A, B, C. A will go to 0 to A dx. Y will go to 0 to B dy. And here is x square, है ना? So x square will also there. X square dx. Y. And this is dz 0 to C. इसमें क्या आएगा? फर्स्ट dx कहां से कहां तक? 0 to A. Second dy 0 to B. Third z square dz 0 to C. Clear है ये? Now,
Yes, sir.
what is this particular thing? M upon ABC. What is this one? A square, sorry, A cube by 3 BC. और ये क्या आ जाएगा?
A b cube by.
A B C cube by 3, है ना?
Yes, sir.
A B, यहां से क्या ABC कैंसिल हो सकता है?
हाँ, sir.
है ना? So what you will get? You will get M upon 3A square plus C square. So this is IYY. So what will be IXX? फटाफट बताओ. What will be IXX?
So y square plus z square, b square plus c square by 3.
M by 3 क्या हो जाएगा? B
B
square
square
plus
plus
C square. What will be IZZ?
A square
square
plus B
plus
square.
A square plus B square. Is that we are going to obey perpendicular axis theorem?
No, sir.
No, because this distribution is in 3-dimensional. Now let's calculate IXZ. So when we will calculate, I can use this space. IXZ. What will be this one? Minus sign will be there. dm. And what do you have? X into
X.
Z. Okay. So we will just go for M upon ABC. dm will calculate it once. Negative sign will be there. And what do you have? X dx. Y dy. 0 to A. 0 to B. What you will get?
सर जेड डीजेड होगा.
Sorry, Z dz. Sorry.
M a c
Z
by.
dz और dy भी होगा ना? And dy is also there. क्या आएगा ये?
minus m a c by 4.
Minus m ac by 4. Okay. So now we can write all the component. Ix y is equal to I yx. What will be that thing? क्या होगा? Symmetry देखकर बताओ.
माइनस ए में बी बाई 4.
Minus m ab by 4. यहां लिख रहा हूं. I xz is equal to I zx तो लिख ही दिया. क्या है ये? Minus m ac by 4. ठीक है? Last but not the least, I YZ is equal to I ZY. What will be answer?
minus m BC by 4.
BC
Minus M BC by 4. ठीक है? Agreed? And now you can easily calculate principal moment of inertia for the case A is equal to B is equal to C के लिए principal moment of inertia निकाल सकते हो. निकल जाएगा ये? है ना? Just you have to calculate the eigenvalue. Okay? So we have just finished it for the Cartesian coordinate. Tomorrow we will go for some problem mainly on polar coordinate, spherical polar coordinate, and then we will go for moment of inertia, two theorem of the moment of inertia, parallel axis theorem and perpendicular axis theorem. So tomorrow we will just try to, and we will do lot of problem actually. Okay, हम लोग अलग-अलग problem करने की कोशिश करेंगे. Mainly perpendicular and parallel axis theorem where masses are going to vary. Density is not constant. This type of question is very, very important for your exam. Okay. And then we will go for center of mass and all this thing. ठीक है?
Yes, sir.
And we can go for center of mass tomorrow also. We can go first, we will go for center of mass and then we will go for all other thing. ठीक है?
Okay,
चलो.
sir.
So just do practice. This topic is just based on practice. है ना? ठीक है? चलो. Thank you.
Thank you,
Right,
sir.
sir.